Okay, our last little bit of solving systems work we're going to mess with, and when you have a calculator handy, it could really speed things up depending on how familiar you are with navigating and rearranging equations. You've already used it to solve by graphing. Then we looked at substitution, which was strictly algebraic, elimination, that was strictly algebraic. Today we're going to kind of veer off a little bit. Just like elimination, I still need to pay attention to getting them set up correctly. From there, it's a matter of calculator steps and then being able to interpret what you see when you get your result. So first things first, we need to line up variables just like elimination. Okay, so when I look at my first equation, it's already in standard form. We're familiar with that, so we're going to leave it like it is. 6x minus, I am going to put the 1 back in front of the y because it's going to be important that we not forget about that later, equals negative 27. But when I look at my second equation, my x value is on the wrong side of the equal sign. I need to move it over. When we do that, it becomes negative. So we're going to write negative 10x plus, because it's positive 7y, equals 29. Once we have it set up and our columns are lined up like they should be for elimination, at this point we can switch and use the matrix method in our calculator if you want to. You could solve this by elimination at this point, but we're going to move into larger systems with more variables and more equations, and this is where this method will really come in handy. So the first thing we need to do is find the matrix menu, and it's right here above the x to the negative 1 button. So we're going to hit second, x to the negative 1, because that takes me to my matrix menus. From there, we're going to arrow over to edit. And we're going to select just the top one, matrix A. Anytime there's a capital letter inside the brackets like that, that tells us it's just the name. We're going to call it A. It's the first one we're using. If we were going to work with more than one matrix, we'd have to really keep track of which one's A, which one's B. It's just a shorter way of saying the first one, the second one. But we're only going to enter one at a time, so it doesn't matter which one you pick. It's just easier if you go with the first one. And then when you see these numbers up here, 1 by 1, that's not times, it's not an x. It indicates the dimensions of the matrix. And if you kind of play around with the numbers as we enter them, now it says 3 by 1, and see I've got 3 in a stack. That first number right there is rows. The second one is columns. So when we look through, anytime we change it, 2 by 4, now I have 2 rows by 4 columns. You can adjust and rearrange this all you want, it doesn't matter. We need to pay attention to the way our equations look. I have 2 equations, so that's 2 rows, and I have an x variable, a y variable, and then a constant on the other side of the equal, so that's 3 columns. There should look like I could just type my equation straight in there. Okay, so we want to make sure we remember that it's rows by columns. Okay, we're going to set that up to fit whatever we want. And then what we type in here, it defaults to 0, is only the numeric part of the equation. Okay, only enter numbers. So we're setting up a representation of our equation. 6, be careful when you hit enter or if you arrow around that you pay attention to where your cursor goes. Negative 1, negative 27. My next equation, negative 10, positive 7, 29. So we've only entered the numeric part of our equation. A matrix is just a representation. It's a way that within context, if we're working with systems of equations and we know that this matrix has been set up, then when we look at that, we know that it's 6 times some variable minus 1 times some other variable equals negative 27. Typically, we're going to just assume it's x and y. If we have 3, it'll be x, y, z. This is why it's important to write down and keep track of what you started with and then what you entered. So our equation now just looks like this. And again, it's context that tells us this is tied back to that, and so I know that the first variable is an x, the second variable is a y, the last number is just what the equation equals. Once we've got it all set up, we're going to second matrix again. To get back into our menu. And this time we're going to go over to Math. And from this menu, we're going to go down until we get to option B, which says rref and has parentheses. So when we do that, we're going to go all the way down, rref. That stands for Reduced Row Echelon Form. What that's going to do is it's going to give us our, oh, sorry, forgot to tell you to quit. I'm glad that happened though. You have to quit first. Okay? Because it thinks we're trying to enter into the matrix. So once we're finished setting up, quit out of there. Then you can go to your matrix menu, go to Math, go down to option B, and select it. Okay? So if you forget this quit step, like I just did, you won't be able to get any further. You'll still be typing into your matrix. So you've got to quit, then go back into your matrix menu to pick that. Now, when we do that, we're going to get something that is called an identity matrix. And so in ours, since it's set up this way, we're going to see 1, 0, and then some number, and then 0, 1, and then another number. The identity matrix is what you get when all the other operations have been undone, and it literally says, because this matches the same layout, and because we got this from an equation that had x and then y and then our constant, I can read this as 1x plus 0y's equals some number. So literally x equals whatever the number is, and 0x plus 1y equals, or y equals whatever the number is. And you're always looking for these diagonal ones right here to tell you that it has successfully calculated what values go in there. So when we pull up the rref on our menu, we do still have to go back and tell it which one we want it to do that to. So we're going to hit second matrix and then just select A. So again, second matrix. And then we're just going to hit enter to select. Okay, so give me the reduced row echelon form of matrix A that I already set up. We'll hit enter. And the information I get back says 1, 0, -5, 0, 1, -3, which tells me x equals -5, y equals -3. I can still write the ordered pair, -5, -3. Either way is acceptable. Okay. We're going to practice a lot in class, but you're going to need these steps to refer back to.